6.3, I have one more set of identities I want to talk about, and then I've got the problems I want you to practice. 1 to 75 odds, but you can restrict yourself to radians only. I'm not going to do anything with degrees, okay? So everything with radians. I have some Pythagorean identities. There are lots of trig identities that you're going to need all the way through diffie-qs for my engineers. For my bio students, chemistry students, computer science further, I need it through Calc 1 and Calc 2. For my computer science students, I need it all the way through linear. So basically 4 more semesters for most of you. For chem and bio, 2 more semesters. So Pythagorean identities come from Pythagorean formula. By the way, known in China in 4000 BC, known in Egypt in 2000 BC. So it's accredited to this Greek mathematician because he published it, I guess, so I'm not sure. But if I have a right triangle with legs A and B, I know A squared plus B squared is C squared, right? If I replace that with X and Y and 1, a radius of 1, now what do I know? Say again? Okay, X squared plus Y squared is 1, yes. But better than that with my trigs, what is X? It's which trig? You gotta yell at me, I can't hear today. Which trig is X? Cosine. So sine squared is Y squared, right? So sine squared theta plus cos squared theta is 1. And that makes sense, doesn't it? If you think about it being on the unit circle with the radius always being 1, right? And I've got a right triangle, right? Should make a little bit of sense. So this is my first Pythagorean theorem, Pythagorean identity I want memorized. In fact, it's the only one you need. Sine squared theta plus cos squared theta is 1. If I solve this for cos squared, I get cos squared theta equals 1 minus sine squared. Again, you don't have to only memorize the first one. That one will come easily. If I solve the first one for sine squared, I get sine squared theta equals 1 minus cos squared theta. So there's the first of 9 Pythagorean identities that you need to know. And we're going to use them very soon, okay? I want to start with that same, the only one I need you to memorize, sine squared theta plus cos squared theta is 1. And I'm going to divide everything by cos squared. I'm going to divide everything by cos squared theta. And what do I get? Tan squared theta plus 1 equals secant squared theta. There is the fourth identity that you need to know. When I say need to know, it's either on your formula sheet, it's either memorized on your formula sheet or you get the tattoo. I would suggest formula sheet. I want to solve this for tan squared. So I get tan squared theta equals secant squared theta minus 1. And if I solve it for 1, I get 1 equals secant squared theta minus tan squared theta. There are the second 3 of 9. Only had to memorize 1. The first one, sine squared plus cos squared is 1. I'm going to start there again. But this time I'm going to divide by what? I know. It's tough. Instead of dividing by cosecant, we're going to divide by sine squared. Yeah, that's my only other choice, right? If I divide by 1, it's kind of boring. So I'm going to divide by sine squared. And I get 1 plus cotangent squared equals cosecant squared. Right? 1 over sine is cosecant. And so from there, I could solve for 1. I get cosecant squared theta minus cotangent squared theta. Or I could solve for cotangent squared, and I get cosecant squared minus 1. So there are my last 3 of 9. Again, only 1 has to be memorized. Sine squared plus cos squared is 1. All right, we got our odd properties. We got our the periods, the domain, the range. We have the Pythagorean identities. We're ready to do some problems in 6.3. Start working on your formula sheet, right? So I would say you could make one just for this next test, but why not work on the one for the final? So everything on it, right? Everything on it. All right, here we go. Let's do some problems. So you'll see I'm going to do a couple of these problems. You'll be like, oh, wait, you already taught me how to do that. Yes, correct. I'm not necessarily teaching it exactly the way the book is going. I'm teaching it the way I understand it, right? So, but let's look at and again, I'm saying radians, right? So like 23, 17 pi over 4. Secant of 17 pi over 4. 6.3, number 23. So, like, I don't even know why you would do this, but you can. You can do it on the unit circle, but you still got to get there the same way as me, right? We gotta cut pi into 4, which means the whole pizza into 8. Everyone comfortable with that? Pi over 4 is my reference angle. Everybody comfortable with that? And I just want the 17th slice of it, right? So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What do you know? 17 pi over 4 is exactly the same as pi over 4. Exactly the same place. So what do I know about that particular piece is that no matter what trig I ask you for, it will be positive. Right? So secant of 17 pi over 4 is 1 over cosine of 17 pi over 4. I don't think in terms of secants, I think in terms of cosines. So if I give you a secant, you want to think of the reciprocal cosine. And cosine is positive, so this is the same as 1 over cos of pi over 4. I look at my reference table and I see that that's rad 2 over 2. And then I get it to look nice. So keep, change, flip, 2 over rad 2. Rationalize. And I get just rad 2. Easy. No? Easy? Yes? Tell me, just lie to me. Say, yes, it's easy. It's easy. It is, right? You got to practice. Can we do another? 1 second? Sure. Yeah, ready? No, sorry. Sorry, Ben. Now, can you check these with Desmos? Hell yeah. What would I do? How do I check this with Desmos? Right? I'm gonna go secant, right, of 17 pi over 4. And check it with my square root of 2. Right? Make sense? Let's do another. Ben, yes? Good? It's kind of boring. We might as well do 25. Tangent of 19 pi over 6. Right? So it's 25, tangent of 19 pi over 6. So what's my reference angle? Pi over 6. So that means the whole pizza into 12, right? You got lots of younger brothers and sisters or something, right? You want the pizza cut up small. And I'm going to count 19, but I don't have to count to 19. I can count to 12, right? And then 7 more. Does that make sense? Because all the way around is 12 of the slices, and then 7 more. So all the way around is 12. Halfway around is 18. 1 more slice. So it's right here, right? There's my 19 pi over 6. And of course, if you're in doubt, you can check yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, 19, I missed one somehow. Doesn't matter. It's there. It's got to be a bow tie. If it's not a bow tie, you did something wrong. Okay? So what's the tangent in that? What kind of slope do I have there? What kind of slope is on that hypotenuse? Positive or negative? Positive. So this is a positive tangent of pi over 6. And what's the tangent of pi over 6? Very good, class. Rad 3 over 3. You'll have them memorized. The more you practice, the more you'll have them memorized. I remember getting my trig test or my pre-cal test, and I would just turn to the blank page and write down the table, because that's all I needed was the table. We can check it on Desmos, yes? I need 19 pi over 6. I need the tangent of that, right? And then I want to check square root of 3 over 2, right? Oh, over 3, sorry. There it is. How we doing? Okay? Back to the book, number 35. It tells me that sine is negative 3/5 and cosine is 4/5. And it wants me to figure out the other trigs. So sine is negative 3/5, cosine is 4/5. Figure out the other trigs, all 6. So this is number 35. So sine of theta is negative 3/5. Cos of theta is 4/5. What quadrant am I in? Fourth quadrant is correct. I need sine to be negative and cosine to be positive. I need to be underground to the right. Right? Sine is a y value. So if it's negative, it's underground. And if it's cosine is an x value, so it's to the right. Right? I'm pointing to the left for me, but it's to the right for you. Right? So I know I'm over here. I like to redraw the triangle kind of free of the axes. And so I know that the hypotenuse is 5. I know the base is 4. And I know the height is -3. Does everyone agree? It gave me the ratio of opposite and hypotenuse and the ratio of adjacent and hypotenuse, so I know every side. So what's my tangent of theta? Nice. And my cosecant, I'll put my cosecant up here because I want to relate sine and cosecant as much as I can, so I get it memorized that they're reciprocal. So that's what, -5/3. Secant and cosecant, secant and cosine are reciprocal, so 5/4. And tangent and cotangent, so -4/3. Everybody okay there? Doesn't seem like anything I taught you today is of value yet. I don't really think so either, but it will be soon. Okay? But these should feel kind of easy, do they? It's just I gave you a bunch of rules and you got to put them together. Yes, it sucks. Somebody let Jose in, please. Yvonne, you mind? Ivan, sorry, I do it again. So used to Yvonne. Yeah. So they gave me this, right? And then I had to figure out everything else. But what did I do first? I figured out what quadrant I'm in. Ready? Nice. 49. It says what? It says cos is -1/3, and where am I? Look at 49. Can you see it? It says cos is -1/3, and which quadrant am I in? Number 49. It says cos of theta is -1/3. So how about this? What's my only choice for quadrants? I got two choices when cosine is negative. 2 or 3. And it says that my angle theta is between pi/2 and pi. Right? So that's got to be quadrant 2. Right? Because this is pi/2 and this is pi, right? So here's my triangle I'm dealing with. What do I know about the base? How big is the base? -3. I'm sorry, -1, right? It's adjacent over hypotenuse. The base, the hypotenuse is 3, and the other side I don't know yet, right? I'll call it a. So a squared plus -1 squared, it's got to equal 3 squared. A squared plus 1 is got to equal 9. A squared is equal to 8. A is square root of 8. which is 4 times 2 is 8. So I get A is 2 rad 2. Once I have all my sides figured out, I like to redraw my triangle. You don't have to. It's just me. That's the triangle am I using. Is everybody okay with that solving for A? Now I want the other 5 trigs. So what's sine of theta? Two rad 2 over 3. Cos of theta I already know. What's the tangent of theta? Yep, negative 2 rad 2 over 1, so negative 2 rad 2. What's the cosecant? Three over 2 rad 2, which is 3 over 2 rad 2 times rad 2 over itself, which is 3 rad 2 over 4. Rationalized. Is that okay with everybody? What's the secant of theta? And what's the cotangent of theta? Easy. Easy, right? Sina, easy or not? You sure? Draw a triangle. So here's the thing, is if I give you a trig, you have a triangle. If you know 2 sides of the right triangle, you know the 3rd side, right? And then you could answer all of the other trigs. Let's do another. Yes. Good. How about 53? It says the secant of theta is 2 and the sine of theta is negative. Secant of theta is 2 and the sine of theta is negative. Sorry, 53. Secant of theta is 2. Sine of theta is negative. Well, if sine of theta is negative, it has to be which 2 quadrants? Sine is a y value, right? So it's got to be 3 or 4. But secant is the reciprocal of cosine. So cosine must be 1 over 2. So it's got to be in quadrant 4. Because cosine is positive, sine is negative. Hey, and it's okay to go out anytime you want to, but just don't if the door is shut, don't let it clasp the lock, right? If you go out, just so Ivan doesn't have to go to school and work the door. So I like to redraw. Once I figure out where my triangle is, I like to redraw it and label. So cosine is adjacent over hypotenuse, so 1 over 2. And I don't know the other side, I'll just call it A. So I know that A squared plus 1 squared is equal to 2 squared. So A squared plus 1 is 4. So A squared is 3. So A must be the square root of 3. Better yet, negative, right? Because it's a y value that's moving down. So we have to figure out sine. We have to figure out cosecant. We know cosine. And we know secant. We have to figure out tangent, and we have to figure out cotangent. Who's got the sine? Yeah, negative, yep. So negative rad 3 over 2, right? Cosecant is the reciprocal, but we want to rationalize with rad 3 over rad 3. So we get negative 2 rad 3 over 3. Is that okay with everyone? Tangent is opposite over adjacent, so minus rad 3 over 1, or just minus rad 3. Cotangent is minus 1 over square root of 3, or minus 1 over square root of 3 times square root of 3 over 3, square root of 3 over square root of 3, sorry, minus square root of 3 over 3. Done. What's the process? Figure out what quadrant you're in, draw the triangle, figure out the sides, answer all the trigs. Pretty easy. Figure out what quadrant you're in, draw the triangle, figure out the sides, answer all the trigs. Right? Yes. Thank you. Well, I gave you these other properties. They're not really that much use in this particular section, but that's fine. That's fine. So you can do all of those problems already. Let's move on to the next section. Yes, I know you have a headache, but it will be over very soon. That's what the dentist always says anyway, right? So we're going to do 6.4 today. We'll leave 6.5 and 6.6 for Wednesday. 6.5 will be very quick. And remember, you're going to be doing all of this graphing on Desmos. So the graphing, don't let the graphing bother you. How many of you are, oh, I hate doing the graphs? How many? There's a lot. There's usually half the class hates the geometry. The other half the class just loves doing the solve for x. Who doesn't like the geometry, the graphs? Jose? Don't like the graphs. Even if it's a calculator, even on Desmos? Yeah. Only Jose doesn't like the graphs? That's unusual. Usually half the class doesn't like it. Rafi doesn't like any of it. So I want to look at the ultimate graph for sine or cosine. And so it's going to turn into this. Y equals A plus or minus A times the sine of B all times X plus C, all of that plus D. And I put them in order A, B, C, D because that's the way I want you to think of them, okay? So A is my amplitude. If you play music and you turn up your amplifier, it's making the speaker rotate deeper. So in actuality, what it's doing is changing the radius. This is the radius of the circle. B is called the frequency. If you could watch a speaker vibrate when I play a single note, you would see it vibrating like that. It would just be kind of creating a circle. Look, can you see the speaker rotating like that? Right? It's just kind of rotating like that. If you put your hand on it, you would feel it. Just be careful, don't break it. If I make the note an octave higher, the speed goes twice as fast. So frequency is speed that a point is moving around a circle. You already know what X is, or C is, sorry. Right? What is it? It's my horizontal shift. And D is the vertical shift. So let's get on to Desmos right now together. And I want to create this with sliders A, B, C, and D. Right? You with me? It doesn't like my curly brackets, my square brackets. There we go. Tell me when you're there. Anybody still not there? Horizontal shift. Left and right, yep. I want to set A as 1, B at 1, C at 0, D at 0. C at 0, D at 0. And I want to graph the mother function y equals sine of x. It really helps to change our Is everybody okay here? You're with me? I want to go to, you see the wrench in the top right corner? I want to change to quadrants. So I want my x values to shift every pi over 2. So I'm going to the wrench, and I'm changing my step in the x-axis to pi over 2. Now you can really see my sine function with a period of 2 pi. You see that? Here's the sine function. We're going to start at the origin. Right? My wave goes up, my wave goes down, goes back to the beginning. I'm at 2 pi. That's the period when it starts to repeat. Right? Does that make sense? Everybody with me? Watch what happens when I change A, the amplitude. When I change the radius of my circle. When I increase the radius. Question? Eli? Oh, yes, you're right. It should be out of the parenthesis. You're right. Thank you. Make sure you've caught that one. So look at the amplitude change, right? Look at that amplitude change. What if amplitude is less than 1, right? Then it's squashed down, right? Remember those vertical compressions, right? And then if A is negative, right? You see it's the sine function upside down, right? Here's my original sine function. Now it's upside down, right? Opposite y values. Let's move A back to 1. And look at what happens when we move B to the right. So make B 2. Make the frequency 2. That means when the frequency is 1, it was 1 sine curve. When it's 2, it's 2 sine curve. So look inside my period here, right? Yes, see it? Talk to me, I can't see you. You see it, the sine curve in black? Look at the sine curve in blue. It's the same thing twice. Twice as fast around the circle. 2 times inside of the 1 period. If I make B 3, again, look at only this period from 0 to 2 pi. Look at how many sine curves I have now. 1, 2, 3. 3 times. The frequency is 3 times as much. Have you heard of AM amplitude radio? AM radio is amplitude modulation. We're changing the height of the wave. Frequency modulation, we're changing the speed of the wave. So when I'm listening to FM radio, I'm always listening for how fast the waves are hitting the antenna. When I'm listening to AM radio, I'm waiting for how long between, right? How wide of the wave is, how big the wave is. Let's set B back to 1. And if I move C to the right, notice the shift moves, the graph moves left. If I move C to the left, the graph moves right. And D is just an up and down. Where it gets hideous in section 6.6 is when I put all of them together. When I make you do all 4 shifts at once. Hideous. All right, we already did this, but let's do it one more time and then get the hell out of here pretty soon, okay? So 6.4, graphing sine and cosine. I want to be able to draw the standard graph first, the mother function first, always. So we know a couple of things about the mother function. The period is 2 pi, which makes sense because it's just moving around a circle, right? The range is all reals, and the domain is all reals. Yes, exactly. So this is y equals sine x only. So C is 0, D is 0, A is 1, B is 1. Yes, good call. Domain is all reals, range is from -1 to 1. And I want to think of the quarter steps as pi over 2s. So when I go to do anything with a sine function, when I'm solving trig equations later this semester, when I'm finding critical values of a derivative in Calc 1, when I'm integrating a trig function in Calc 2, I want to be able to draw this picture anytime I'm talking about sine. So I'd like to see at least the first circle, maybe a little bit more. And I want to be able to draw my quadrants quickly. 1, 0, 1, 2, 3, 4. They are pi over 4s. So meaning this is 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4. And 4 pi over 4. It'd be nice to go a little further, left and right, but you don't have to, because I want to focus in on this mother function box. I know my heights have to go up 1 and down 1, so I'm really thinking of this box for my mother function. I know in quadrant 1 what happens to my sine. It goes from 0 square root over 2, 1 square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So it's building up to 1, starting at 0, building up to 1. Then it's got to come back down, all the way down to -1, right? And again, I'm thinking of unit circle. What's happening to the heights of the triangles in quadrant 1? They're going up. Then what's happening to the heights of the triangles as I go to there? They're going back down. Heights of the triangles as I'm going here, back down to -1, right? So I can see now my sine curve right there. Boom. It repeats, so I should be able to continue the sine curve left and right of where I am. But I really want to focus on that box, right? That box of a height of 2, width of 2 pi. Cut into 4 pieces, the quarter steps. Yes, you with me? Two pi. So when does the pattern repeat again? 2 pi. Oh, I made a mistake. It should be 1 pi over 2. Sorry, 4 quarter steps. Sorry. Thank you. Screwed up. Over 2, sorry. Right, pi over 2s. First pi over 2, second pi over 2, third pi over 2, fourth pi over 2. Thank you. So what's nice about this, if I had to draw y equals 2 sine x on here, all I have to do is think about the amplitude change, right? Do you see that? It's just the amplitude change. So now the radius of the circle is not 1 anymore, it's 2. So meaning I should be able to extend my box from -1 to 2. There's my same box. my same quadrant angles. Yes, you with me here? But it starts again at 0, goes to the max height, goes back to 0, down to the lowest height, back to 0. So there's y sine 2 sine x. So once I get the mother drawn, it's easy to do an amplitude change. It's easy to do a change left or right. It's easy to do a change up or down. Right? What am I doing with the amplitude change? I just stretch the box out, right? What am I doing with a change, a shift to the left? I'm just taking the whole box and moving it left. What am I doing with a shift up or down? I'm taking this whole box and moving it up or down. Right? We did this before in chapter 2. But not with the trig. Right? Let's do the mother function for cosine. So again, the period is pi. The domain is everything. The range is -1 to 1, inclusive. The quarter steps are again pi over 2s. I want to kind of get in the use of the habit of being able to see the mother function to the right, the mother function to the left. But I'm really focusing in on that one box of a height 2 and a base of pi over 2. So I've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, right? Those are my quadrants. You can see quadrant 1 here, quadrant 2, quadrant 3, and quadrant 4. Where does cosine start? Sine starts at 0, right, and builds up. Cosine starts at 1 and gets smaller. So cosine starts at 1, gets smaller, and then builds back up. There's my cosine curve. This is the main box I want to think about. Because if I gave you something like y equals the cosine of x minus 1, I'm going to shift the whole box down 1. And there's my cosine x minus 1, almost, right? Horizontal, vertical shift. So I want to be able to draw the mother function for sine and cosine. Let me see if there's problems I like in 6-4. I doubt it. No, wait for me. I mean, you can start to read it for sure, but wait for me for next week. Yeah, wait. Okay, ending a little early today so I can talk to a couple of you. If you want to talk to me about what's going on with the class, how you're going to move forward, feel free to come talk to me, right? And Emmanuel and Wankuni, I want to talk to the two of you privately. On Blackboard, if you go, did I put the My Grades tab up there? Let me see.